Layers. Armand Shariarian. Layers. As Donkey in the movie Shrek suggests, layers are important. Actually, Shrek says that ogres have layers, and Donkey says cakes have layers, but Shrek likens ogres to onions, and cake is better than onions. Plus, I still hear Eddie Murphy as Donkey say, ink cakes have layers. None of which is really the point, of course. Except for cake. Cake may be the point because when we talk about networks and communications between systems, we usually talk about layers. If you think about a 7-layer cake with thin layers of cake, you may be able to envision the way we think about networks. Plus, in order to envision the best process, you'd need to envision 2 slices of cake. 2 slices of cake have to be better than 1 slice of cake, right? Figure 2 to 3 shows a simple representation of the 7 layers of the OSI model and how each layer communicates with the same layer on remote systems. You can imagine that the lines between each of the layers is really icing and maybe jam, just to make it more interesting. Plus, the jam will help the layers adhere to one another. Since it's sticky, each layer on every system you are communicating with is exactly the same, so when you are sending a message from one slice of cake to the other slice of cake, it's the same layer that receives it. Figure 2 to 3. OSI model showing system-to-system communication. Let's think about it this way. Our first layer at the very bottom is the physical layer, so we can think of that as pistachio. Our pistachio, physical, layer is where we connect to the network or, in this case, the plate that the cake sits on. As with cake, nothing is between the physical layer of the system and the network. You take your network interface and plug a cable into it, connecting it on the other end into a jack. That's all. The physical layer. In our cake, the pistachio sits directly on the plate, with nothing between. Our next layer, which has to pass through icing and jam so the operating system can distinguish between one layer and another, is dulce de leche, think caramel made from milk. This is our data layer. The addressing of this layer is done using the Media Access Control (MAC) address. This address includes 3 bytes that belong to the vendor, sometimes referred to as the Organizationally Unique Identity (ER), or WI. The other 3 bytes, since the entire MAC address is 6 bytes long, are the unique identifier for your network interface. The 2 components together are the MAC address. Any communication on your local network has to happen at this layer. If I want to talk to you from my dulce de leche to your dulce de leche, because who else would understand dulce de leche but another dulce de leche, I would need to use the MAC address because it's the only address that your network interface and my network interface understand. The address is physically wired into the interface itself, which is why it's sometimes called the physical address. In example 2 to 1, you can see a MAC address in the second column from the output of the program ifcang. Example 2 to 1. MAC address Ether 52:54:00:11:73:65 sculin 1000, Ethernet. The next layer we come across, again crossing through our icing and jam to clearly distinguish one from the other, is Nilla wafer, vanilla, and our network layer. At the Nilla wafer layer, network, we address using IP addresses. This is also the address that enables us to pass outside our local network. The MAC address never passes outside the local network. The IP address does, though. Since we can communicate with different bakeries, all having cakes designed exactly like ours, using IP addresses, this is the layer that enables routing. It's the routing address that allows us to get directions from one bakery to another by using the IP address. Example 222 shows an IP address, which is comprised of 4 bytes, sometimes known as octets because they are each 8 bits long. This is a version 4 IP address. Version 6 IP addresses are 16 bytes. 128 bits, long. As with the earlier example, this is from the output of IFCANG. Example 222. IP address. INET 192.168.86.35 netmask 255.255.255.0 broadcast 192.168.86.255. The fourth layer in our cake is the tea berry layer, transport. Yes, it's going to be a strangely flavored cake, but stay with me. Plus, if you don't know what tea berry is, you should find it. Tea berry gum is very good. So, the tea berry layer gives us ports. This is another form of addressing. Think about it this way. Once you get to the bakery, you need to know which shelf you are looking for. This is the same sort of thing with ports. Once you have found your bakery with the IP address, you then need to find the shelf in the bakery, which is your port. The port will connect you to a service program that is running and has attached itself to that shelf port. There are well-known ports that particular services run on. These are registered, and while the services, example web server, can bind to a different port and listen on that, the well-known port is common because it's what everyone knows to look for. At layer 5, it becomes challenging, simply because this layer is not always well understood. The fifth layer is strawberry, because we need some fruit in our cake. Even if it's just fruit flavoring. This is the session layer. The session layer is all about coordinating long-standing communications to make sure everything is synchronized. You can think about it as the session layer making sure that when you and I are eating our slices of cake at the same time, communicating, we are going at the same pace, so we start and finish at the same time. If we need to stop and take a drink of water, the session layer will make sure we do that at the same time. If we want to drink milk rather than water, the session layer will make sure that we are completely in sync so that we can start and finish at the same time and essentially look the same while we are eating. Because it's all about how it looks. Which brings us to the peanut butter layer, because what's a cake without peanut butter? Especially if we have jam in our cake. This is the presentation layer. The presentation layer takes care of making everything look okay and correct. The presentation layer will make sure that there aren't crumbs all over the place, for instance, making sure that what you are putting in your mouth actually looks like cake. Finally, we have the amaretto layer. This is the application layer. Ultimately, this is the layer that sits closest to the eater, user. This takes what comes out of the presentation layer and gets it to the user in a way that it can be consumed as the user expects it to be consumed. One element of the cake analogy here that's important is that when you use your fork to get a mouthful, you cut through the layers from amaretto down to pistachio. That's how you load it onto the fork. When it's consumed, however, it goes into your mouth pistachio end first. This is the same way we send and receive data. Messages. They are constructed from the application layer down and sent along. When they are received, they are consumed from the physical layer up, pulling off the headers at each layer to expose the next layer. As we are working on network testing, we may be working at different layers of our cake. This is why it's important to understand what each layer is. You need to understand the expectations of each layer so you can determine whether the behavior you are seeing is correct. We will be dealing with testing across multiple layers as we go forward, but generally each tool we will look at will target a specific layer. Network communication is about consuming the entire cake, but sometimes we need to focus our efforts, taste buds, on a specific layer to make sure that it tastes correctly all by itself, outside the context of the rest of the cake, even if we have to consume the entire